Hey y'all, I am going to put together a little video of chapter 8, or not chapter 8, oh gosh, number 8, basically part C of our worksheet, number 1, and this is a unique one. This is the one we struggle with the most. It's forces acting on an area, but I'm hoping that all the work we did in the previous chapter starts to make sense in this one once we put numbers to it, okay? So if I were to redo anything, I'd redo all this using numbers. So I've got a kid, 30 kilograms, going down a slide with an angle of 55. So let me get that up. Sorry, new location. Today was trying to figure out how to get wireless for this setup. I'm going to make a slope. Right, and I'm going to put 55 degrees down there, and then I'm just going to use, I know I can use a box, I can use a dot, I might use a dot this time, just to not offend the child being boxy. Anyway, so what we have to think about are our forces as the child slides down, okay? I hear someone chiming in, yes. Force of friction. We love force of friction. Or not force of friction, force gravitational, right? Force due to gravity, right? Now we could calculate that really quick. What was the mass of the child? Was it 30 kilograms? So if it asks for a quantitative, so I like to do quantitative right away, okay? And that is going to be 10 newtons per kilogram times our mass. Right, so 10 times 30 for 300 newtons, so 300, okay? What other forces are there? What other forces are there that are exhibited or present themselves? Oh, yeah, I hear it, normal force. Now, normal force is perpendicular to the surface, so it goes out here, okay? This is force normal, okay? And the last one we've got, well, before we go to the last one, can force normal equal force gravity? I don't know if you remember when we had that mass on the scale and we tilted the mass. So if this is my scale, and we had a mass on it and we tilted that mass, we saw the scale reading change, right? That was the normal force. The scale reading usually represents the normal force. If I tilt that sail, it got less and less and less, okay? So force normal does not equal force of gravity. One, they're not even in alignment, okay? So the common error is to draw force normal in line with force gravity, and that is not true. Force normal is perpendicular to the surface. And then the last one they mentioned, right, was force of friction, okay? What they say, was it 160 newtons? Okay. So I am not going to solve the whole thing, but I want to give some hints, okay? Which way, if there's going to be acceleration, will it go? Right? It's going to go down the hill, right? Acceleration is going to be down the hill. That's an A, okay? That means the net force is going to go down the hill, or parallel, okay? Is it going to go off the slope? Nope, it's going to ride down that slope. The kid's not going to just immediately pop off the slide, only if it goes over a hill, and we'll actually study that later with rotational or circular motion. But we're going down, so the net force has to go down, but I don't see any forces going down, okay? That's when we get to gravity's influence. Part of gravity is pulling us in to the slide, right? Anyone who's gone on a hot slide knows you are in contact and it hurts, right? You've got that pull into the slide, but also you felt when there's been a little too much friction and your skin, instead of riding on your shorts, your skin hits and you start skidding down, and that stings too, right? So I've got force of gravity that's perpendicular to the surface and force of gravity parallel to the surface, okay? So now, if I've got acceleration parallel, right, this force of gravity's got to be greater than this force of friction if it's going down the hill. If the kid just stuck, then force of friction, right, is going to be equal to the force of gravity. And we'll go over friction next week. Okay? Now this way, are they accelerating perpendicular? No. So these two are the same. So the last hint I'm going to give you is what is either this angle or that angle, because I know these are perpendicular. Okay, so my emphasis on free body diagrams at angles was so important for this unit. So hopefully we've got some background in it, and we start refining our diagrams. So let's try to figure out the angle. If I drop this down, I create this right triangle, right? Right triangle. So if this is 55, this has to add up to 90, right? What would that be? Not 45. This would be 35, okay? So then what would this angle be, right? Well, this forms a right angle here and here, so this would be 55 degrees. So now I've got a right triangle, okay? I've got a right triangle, force of gravity, 300. And this is 55 degrees. Can you find, you can just call it y, and the x values of that right triangle using trigonometry? So that's your hint, that's your guidance for setting up the problem. You're going to have to find these components and see the equations perpendicular, right? Perpendicular to the plane and parallel to the plane, okay? Find those components and you can solve this diagram and find the acceleration. I hope that helps.